டேய் வா அடிச்சிருவேன். எனக்கு உண்மை மேல விடுங்கடா. நான் சொன்னா செய்வே செய்ய மாட்டியா? மேல விட்டுட்டோம். Hello. Good evening. Hello. Good evening. Hello. Hello. Hall. Hello. Hello. Good evening.
So
Hello,
I
good evening,
request you
sir.
to please share your screen, sir. In the same meeting window, you can see
Actually,
a
the blank
upside arrow
recording
key
is going,
there.
sir.
Yes, sir. My voice is audible.
Yes, sir. Very well.
Next to the camera icon, a upside
Yeah. I just it's already recorded, sir.
we are talking.
Yes, sir.
Yeah, it's already recorded. Yeah. So far, good evening to all. How many students have been joined?
Sir, no one has joined yet.
Yeah. Okay. What's your name?
Bottom
Good name. Hello.
Yes, sir.
Share
Yeah,
a
what is
screen.
the-
Then select entire screen
Okay. I'll share.
and select the inner window and
You are, sir. You are coordinator, sir.
Yes, sir. We are from the admin team.
Great,
MS
sir.
Teams
Thank
lecture.
you. Thank you.
Yeah.
Now,
Hello.
Yes, sir. Visible. Screen is visible.
Yes, sir. Good evening, sir. So far, it's common link for everyone, right?
it will start.
Yes, sir.
In time
Yeah,
it happen. No problem.
Yeah. Thank you. Hello. Anyone who joined this session? Good evening. Hello.
Tick mark.
Sir,
tick
no
mark.
one has joined.
Yes.
Okay, sir.
Yes.
Okay. If anyone has joined means I will take the class so that I'm waiting for any one person.
Okay, sir. Okay.
Yes, sir. Thank you, sir.
Sir, if you have any WhatsApp group, so you can announce the students to join the
Ah,
session.
No, sir. I'm not having any WhatsApp.
It's a
group.
setting up, na?
Okay.
Yeah. Okay, so let us start it. Let them come one by one. Yes, good evening to all. Okay. So as per the sessions, hello guys. Hello guys. Anyone on join? Hello, guys. Anyone want to join? Good evening. Coordinator, sir. Hello, guys. Okay. Anyone want to join, guys? Okay. Okay. Just going to run a program that is in data structure. Remaining 5 programs are there. The first, totally we having 10 programs. In the 10 programs, we're going to start the lab exercise number 6, 7, 8, 9, 10, 11. So before that, I'm going to start the session on. I'm going to start the session on visual coding. So how to execute your code? How to execute your code? Hello, anyone have joined? Hello, 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 all guys. Hello. Hello, guys. Hello. Anyone is there? Hello. So they're going to run a sorting technique. So this is sorting technique here using one of these sorting technique from example bubble sort. The sorting it consists of merge sort, quick sort, bubble sort, keep sort, and so on. So I will explain each and every segment very clearly. So this is a online, this is a swapping, sorting in elements using swapping, right? So here you can able to see how the coding is arranged. Or the coding, see here you can able to see about how to declare the each and every variable I comma j comma temp file and using a printf. Just we're going to print a numbers. We're going to print a numbers. So we're going to print a numbers here. From there you can able to see a sorting bubble sort logic. So this is a for loop. Inside the for loop there is another for loop is there. One for loop is there, another for loop is also there. Inside the for loop, there's another for loop is there. So here is if a of I is greater than a of j, temp equal to a of I equal to a of j equal to temp. This is swapping the elements. And this is used for printf. This is going to, after swapping, this is used for the ascending number, ascending order. Okay. So here come example, just going to use this coding again. So, hello. Anyone have joined? Hello, guys. Anyone is there? So this is coding. Going to see about that. This is used for the sorting. Okay. The thing. So last class, I've been heard about that. A few more doubts. A few of them, as many more, are having some doubts in that last assignment. So how to run the code and how to use this code. You can able to see this coding. This is a multi-level task management systems with undo or redo. Right. This is a background they gave about the project. Often handle complex projects with the multiple tasks and same task assigned to different team members. Tracking with each other, each task and dependencies and completion status can be a challenging task. Right. A robust system is required to manage a task, additions, completions, and changes, including the ability to efficiency and redo action. Using the stacks queues is ideal for maintaining the operations history, supporting undo or redo functionality, and preserving the task order. The problem description is you are required to design a task management application in C that allows user to add task and subtask, sort task and subtask, and mark task as completed, undo the last action, whether the adding a completion is task, redo the last undo actions, display all the pending tasks in a hierarchical order, showing the subtask under their parent task. So each task must have a unique task ID in the format, year, project code, serial number, right? The requirements you might see about that. What are the requirements they're asking? The system should support multiple levels of task, subtask using a suitable data structure. And undo or redo functionality must handle the nested action correctly. Task additions and completion should update the pending task list effectively, efficiently. And fourth point is display tasks in the order they were added with the subtask intended under their parent task. Implement error handling for the invalid operation. Example, completing a non-existence task or undoing when the task is empty. And sixth one is each task ID must be unique. If a duplicate is entered, display an appropriate error message. Then functions to implement. So initialize task manager. Initialize a task manager. Initialize an empty task list. Undo task and redo task. Add task nothing but add task manager, task ID descriptions, parent task ID, add a task or subtask. If parent task ID is empty or not found, treat it as a top level task. And third one is a complete task is a task manager, task ID. Mark the given task as completed. Undo or redo. Undo means a task manager. Undo the last add or complete operation. And redo is a task manager's. Redo the last undone operation. Display the pending task of task manager. Display all the pendings in a incomplete task hierarchy. And a sample input, enter the number of operations, 5. Add task. So this is a given input, right? So add task, track task ID of this one, and descriptions, design database, add task, task ID descriptions, and this one is add task, task ID of descriptions, complete task. This is a task ID of descriptions. This is a required output. Pending task. So these are all the instructions for the students I gave for this. Use multiple task examples. You can able to use use a stack for the undo or redo history, and a linked list or a tree structure for managing task and subtask. Each undo or redo stack entry should store the type of the operation, add or complete, the task ID, the task data, ID descriptor, parent ID, and completion status. Right? And this is analysis, right? Add task, complete task, undo, redo, etc. The provider is a best case, worst case, average case, asymptotic complexities, a brief justifications, and also they are given the rubrics. I am just listed about the rubrics also. So you can see about that deliverables. Each and every source code is a C language, and asymptotic analysis report, time complexity for all the major functions, and how to run the text file, how to run the file as a text, including compilations and execution instructions and executions screenshots showing the output for all the key operations, evaluation rubrics, category and marks, data structures, add or update, undo, redo logic, display of the task output, error handling, time complexities. So guys, these are all the things I show it now. And the thing is that so guys, it's audible. Anyone want to join? So, hello. Hello. Okay. Just see. Hello guys, anyone want to join? Here, this is a sample code to run our data structure. You can see about that this is a declaration. I'm going to declare all the variables using temp file. This is I'm giving a print of like enter the five numbers. This is a for loop here. In this for loop, I given about the five numbers. This scanf I'm going to read the five numbers. Okay. So just taking about example of bubble sort. So many sorting technique is there. Just taking one of example bubble sort. So this is a for loop. Inside the for loop there is a looping. So this is like a looping for loop. The for loop is there. Inside the another for loop. This condition is used for the condition a of I is greater than a of j, temp equal to a of I equal to a of j, f j equal to a. This is used for swapping, ascending order. So there'll be a collection of all numbers. So I'm going to give the numbers in the ascending order, 1, 2, 3, 4, 5. Just pressing in ascending order here and printing the value. Okay. And you can able to see about the general data structures, the node creations in C, used widely in a linked list and a hierarchical data. And a hierarchical data here, the structures contains data and pointers. Data and pointers. Data means the content of the value stored can be a symbol or multiple fields. Pointers, it is to connect with other nodes. Example, the next node in the linked list or a child, a parent for the trees. Okay. So you can able to see about the data and pointers here, basic node data structures for these examples of linked list. So everyone know about the what's the meaning of linked list, right? So each and every linked list have the nodes and links, right? Nodes. Each and every nodes will going to hold the data. Okay, each and every node will will hold the each and every elements in the node. So each and every node is linked with the each and every another nodes. Example, one node is there, another node is there. Each and every node will be linked with each other. So you can able to see about a type of structure node, data field. This is a data field. This is used for pointer, right? So type of structured node in data, structured node star data, node star means a pointer, node data, node. So each and every node is connected to the each and every other node. Example node is there, which is used to hold the data to the next node. So every node will be connected with a link. So this is a structure used to represent the data field, can be any field, and as this line is used for the pointer to the next node. Okay, so this is a general structure of your uh, this is general structure of your node data structure. For this structure, you can able to see about type of structure data. It is used for multi-level tasking. So it is used for the hierarchical as well as for task management. The assignment one attached now, you can able to use this. So typed of structure task, this is a character task ID 20, unique ID, description of under task description is completed status flag, struct task pointer parent, pointer to the parent task node, structure task start child, pointer to the first child. This is used for the child node. This is used for the parent node. This is used for the next siblings. So this is very, very important to operate the multi-level task. Okay. So likewise, you can able to see, uh, you can able to see about that. I can able to execute this task level in our sample editor to run the coding, sample editor to run the coding here. Okay. Yes, this is the online code here. I'm just going to enter one. So I'm going to enter about that 5 65312. Just enter. Six, 5. So this is a example of this bubble sort. This is an example of its output. Can you able to see the output here? This is the output. Okay. Just entering about the 5 numbers and get the output. So the logic is using bubble sort, and you can able to execute all the codings to this contract. Okay. The same as it is, I'm going to run about that sixth sixth option is insertion sort. I'm going to run about the insertion sort. So after running this insertion sort, can I able to see this insertion sort with 1,000 elements took 0.000854 seconds to an element, and insertion sort with the 5,000 elements will be very less, right? So the same as it is for the insertion sort that 10,000 elements took about at 0.073 seconds, and insertion sorts with the 50,000 elements took 1.775440 seconds. Okay. This is for insertion sort. Can able to see about the coding here? It's very simple coding. Hash include stdio.h, time.h, standard library.h. And void insertion sort, this is a very, very important method. So void insertion sort here, integer array of comma integer n for this is a for loop. For loop, this is a for loop here, less than n I plus plus int key equal to array of I. It's just holding all the elements in an array and assigning to key value array key value here, and this is used for the key assigning each and everything. And I minus one, just I minus one means holding all the variables and decrementing one by one, decrementing minus one and pass it to j value. So what it assumes, it is greater than 0 or equal to 0, and this both condition must be very true, right? And this is also the array of j value must be greater than key value. And the next one is array of j plus 1 equal to array of j, and the next value is a j equal to j minus 1, and array of j plus 1 equal to key. Equal to key. So the next one is int main. Int main in data size equal to the 1,000, 5,000, 10,000, 50,000. So for this for loop, it is used for data size. This is used for initialize array with the random numbers. Okay. So this is used for our insertion sort. the insertion sort. Insertion sort. So this is the insertion sort. This is the insertion sort here. Insertion sort here. It is used for the output. It's used for the output. So what is output? We got it. The output we got it. Insertion sort with the 1000 elements. This is the output we got it, right? So this is the insertion sort here. You can see about the coding has been attached here, and you can see about that output is insertion sorted 1000 elements took for the 0.0094 seconds, and for the insertion sort the 5000 elements took about the 0.021248 seconds, and that's why you can able to see about 10,000 elements going to be inserted. It took for 0.084984 seconds, and the insertion sort with the 50,000 elements took 2.0717770 seconds. Okay, so the thing is that how we can able to use this insertion sort here, how it accomplished, and what is the use of it, the insertion sort. Okay, this is a very important section in this coding, and it is used for this main function. It is used specifically for initialize the array with the random numbers. Initialize the array with the random numbers. It is used for the clock per seconds. How it is used? So in which seconds are going to be execute each and every seconds. Okay, you can able to use this clock seconds. The clock 2 seconds equal to the clock underscore t starts equal to clock insertion starts array comma n and clock underscore t end equal to clock double time underscore taken equal to double ends hyphen start clock per second. Print of insertion sort with the hyphen t for percentage d elements to percentage of seconds slash n comma n comma time taken. Okay, this is used for the seconds. Okay, and going to now wait run over the merge sort. This merge sort is specifically designed. Able to see the merge sort. What's the merge sort here? Each and every there will be a number of nodes will be there. Okay, 1, 2, 3, 4, 5 or something will be node given numbers in the node. Each and every nodes will be able to see this. Going to start over the merge. Okay, what's the thing of the merge sort? Specialty of the merge sort. The merge sort is efficient comparison based sorting algorithm, right? It's a comparison based sorting algorithm. We're able to see the output. What is a comparison based sorting algorithm? So that follows the divide and conquer paradigm. It operates by recursively dividing an unsorted list into a smaller sublist until each sublist contains only one element. So here it operates by recursively dividing unsorted list into smaller sublists until each sublist contains only one element. This merge sort is specifically used for divide and conquer. So divide and conquer. So merge sort. Okay. So example, just I'm giving about the two sorted sublist. Example 1, 5, 9, right? And 2, 4, 9. So I want to use about the two sorted sublist. I want to merge it using merge. So 159 is there, 249 is there. I want to sort it using sorting. I want to merge it. So each and every one, everything have to be sorted accordingly to the ascending order. So the time complexity of this merge sort is 0 of, there is O of n log n. Okay, n log n, and the space complexity is it requires for 0 of n, that is auxiliary space. Needs for the need, there's a due to the need for the temporary arrays during the merging sort. And stability, merge sort is a stable sorting algorithm. So the elements with the equal values maintain their relative order in the sorted output. Okay. So the thing is that the merge sort, example, how can I able to see the merge sort? Example 1, 2, 3, 4, 5, 6, 7, 8 is there. I want to divide this sorting into a off of the this eight blocks is there. I want to divide 4 and 4. In this 4, I want to arrange it properly, right? Then I want to arrange it properly, just even or odd or even. Then I want to go it for these arrangements. Okay, so likewise you can able to use about the sorting techniques. So this wise you want to make it a very order. That is called as a merge. It's a merge sort. Okay, can able to see about this coding. Can able to use this coding for this merge sort. Okay. So can able to see this merge sort hash include stdio.h. This is used for the void merge int or int array of int left and int mid int right. That is a node. In this node, you can able to see about the left mid value, right value, and mid minus left might equal to 1. This is used for the number storing the assigned value to n1, and right minus mid going to going to just splitting a block into two. So left, mid, right. So you want to make a value. You want to make a value that left plus one. You want to add the plus one value to the left and minus the mid value going to assign value to n1. Same thing, the middle value have to be subtracted with the right side, and we want to assign to the n2. So int of L1, comma or right of n2. This is a block used for the left and the mid value. And this is a value, this is a loop condition. This is a condition using while loop. In that while loop, I use the two type of conditions. Okay, control statements. Okay, take used for these control statements, statement else. It is used for these. This is initializing I equal to 0, I j equal to 0, k equal to left here. Why I is less than n1, double ampersand j is less than n2. That's all. And if conditions L of I, this is used for the L of I. It's the smaller equal to R of j. Array of k equal to L of I and I plus plus. This conditions is used for these. Left must be a smaller or equal to R element, an array, and else part is a array of k equal to R of j. And this conditions is specifically used for the while conditions I is less than n1, array of k, L equal to I plus plus k plus plus, j is less than n2. This is used for this j plus plus k plus plus. And void merge sort, it is used for the merge sort array left mid, array mid plus one right. This is used for the left and mid plus one right, and left mid right. This is used for the mid range, that is used for this merge sort. This conditions is specifically used for the left, middle, right. Okay. And this conditions it is used for the data size of 1000, 5000, 10,000, 50,000. It is used for initialize the arrays of random numbers. So checklist and clock values. Okay. And you can see the output here, very clear in this. Guys, anyone want to join? Okay, I just go into the seventh program. The hash value. Can you able to see the hash value? So now going for a hash table, right? The hash value with hash table. So hash table is a linear chaining. This is objective. Understand the content of the hash table and how they work. Learn about the collisions resolutions using a linear chaining. Implement a hash table with a linear chaining in a C. On instructions, hash tables are the data structures that provides an efficient way to store and retrieve data. They use hash functions to map keys to their corresponding values in an arrays or tables. A common issue with the hash table is collisions which occurs when two keys hash to the same index, and linear chaining is a method of collision resolution that uses a linked list to store the multiple values in a single index. Understanding the hash tables and the linear chaining, the hash table structure and how the linear chaining works. Hash table means arrays and linked list. See, this is your lab sheet. This is used for defining structures. We use the two data structures for the linked list. We define two structures, one for linked list and another for hash value. And this is explanation. This is the hash function. And this is used for the hash table creation, malloc, size of the hash table. And this is for explanation. This is a memory allocation memory for this hash table. Initialization sets each index in a hash table to null indicating empty slots. Insertions functions. This is used for your key value pair into the hash tables, and hash index, calculate the index using the hash functions. If no collision occurs, insert the node it directly. Otherwise, it traverses the list and append the new node to the end. And this is search functions. And delete functions pair different hash tables. So these are all the each and everything going to be structured here. Okay. Now going to execute the hash value, hash table. Now I have been running about the hash table, right? I'll be attaching all the insertion sort, merge sort, and lab sheets. Next one. Please check and do practice. Hosha. Okay. H24 and do assignments. Assignments on so here guys you can able to see about that hash table. This is a hash table output also. Typed of structure node. And this one is a typed of structures hash table. And this is a typed of structures hash table. Node value types the table size. This is specifically used for your structured node, structure hash value, table size. And this is used for this hash function is used for your table size. And this is creating a new node. This is used to create a new node. Okay. The new always each and every node will be followed to the next node. And while following, each and every node will be linked. Each and every node will be linked with each other. This is for connectivity. Okay. It is used for your connectivity. It is used for your connectivity. Okay. And this section is used for new node. And this section is used for the initializing hash table. Okay, MLOC, memory allocation table. And this is used for key value pair into a hash table. And this is used for a search for a value by key. And this is a delete a key value pair. Delete a key value pair. It is used for delete a key value pair and each and everything. This is used for the print the hash table. And this main function is used for insertion of each element and print the value and delete value, etc. etc. And you might be seen about the execution value, right? It's the hash table output. This is the output for Guys, the class is going to complete. Any doubts can ask me. Yes, thank you all.